Hello, good evening. Natalie Towery here. I'm here to go through a couple of questions I've already put up for you on straight line graphs. Now, I'm just looking to get the PowerPoint presentation up for you without seeing too many of the answers beforehand. Let's have a look. Here we go. Okay, so here was one of the questions. The first one was, which of the following lines are parallel to each other? Now, we have y equals 2x plus 3. Y equals 3x plus 2, y minus 6 equals 3x, and 3y equals 2x plus 3. Now, I think what does parallel mean? It's quite a key word there. Parallel, we kind of liken that to train tracks. Two lines that will never meet. Now, that's lovely, knowing that, but how does that relate to looking at these equations? Now, if we actually put them in the form y equals mx plus c. So basically, we're making y the subject of these equations. So y on one side, everything else moves over to the right-hand side. So let's do that for all of them. So we have A and B are the same already. For C, we needed to move that minus 6. Now, to cancel that out, we add 6 to both sides. So we end up with y equals 3x plus 6. Another way to think about that is we move it to the other side and it does the opposite. So depending on which way you've been taught, both mean the same thing. And for D, well, we've got the y on its own, but actually there's a 3 attached to it. That 3 is multiplying that y. So to move that 3 over to the other side, it needs to divide everything that's on this right-hand side. So we have 2 divided by 3, which is 2/3, and we have, I've lost my maths, and 3 divided by 3, which is 1. So that's why we have y equals 2/3 of x plus 1. Now, the ones that have the same gradient, the same sort of slope, means that they are parallel. Now, how do we know which is the gradient from our equation? Now, this is where revision comes in. So we've got here natty tip, which you've seen before. So y equals mx plus c. The m is the gradient. So the number that is in front of the x is the gradient, provided it's actually in this form, y equals, and the x is on the other side. The extra bit, the c, which you also need to know anyway, is the c. It's the y-intercept. That's where it crosses the y-axis, and it's also where x equals 0. So moving on then, let's have a look at them. We have 2 here that have exactly the same gradient, lines A and line B. So therefore, they are the 2 lines that are parallel. Job done. So always remember, everything must be in the form y equals something x plus or minus c. All right, so make sure you do that before you look to see what the gradients are. Quite often an examiner will have something in this form or this form, so be very, very careful. Make sure it looks in this sort of form, so y equals something. Right, let's go on to the next question. I'm just going to move this. I'm not quite sure where it's going to end up. All right, so number 2 was a straight line, L1 I'm going to call it, is parallel to the line 2y minus x equals 4x. Hopefully there's something going on in your head now based on the question I've just done. It also goes through the point 5, 6. So x equals 5, y equals 6. What is the equation of this line? Now, I've not really spoken about this much on this site, but what I have done is I put a post up about what I call my steps to success. So what we need to do is think about, what do we know about this question? What's it actually asking us? Well, it's talking about a straight line. So think, well, what do I know about a straight line? Yeah, it's y equals mx plus c, where m is the gradient and c is the y-intercept. And it's talking about the relationship between our x-coordinates and our y-coordinates. So what are they? What's going on there? So what we need to do, if you remember from the previous example, is we need to arrange it so it says y equals something. So first of all, we need to get rid of that -6, send it to the other side, which basically means we're adding 6 to both sides. Now, if you have a look there, we need y on its own, so we need to remove the 2. So we send it to the other side and it divides. Now I've done that already, so we've ended up with 4 divided by 2 gives 2. 6 divided by 2 gives 3. So there's our equation. Y equals 2x plus 3. But the line we're looking for is, oops, put that back again. The line we're looking for is actually parallel to that line. So what is going to be different in it? Have a think. It's actually this intercept here. We don't know what this is going to be, but we do know that it is going to have a gradient of 2. It's going to have exactly the same gradient as this line here. So we know so far, it's always a good idea to do this. Write down as we're going along, what do we know so far? Because that's worth marks to you. And remember, method marks are very important. So we know it's going to be of the form y equals 2x plus something. Right, so what else do we know about this line? We know it goes through the points 5 and 6. And as I said to someone recently, I said, well, if you were forced, you're thinking, what on earth can I do with this? I can't remember what to do. Well, actually, that x, the 5 is an x value, and the 6 is a y value. We have an equation here that involves a y and an x. So how about substituting in x equals 5? I was pointing then, and you wouldn't see me pointing to it. Y equals 6 there, and x equals 5 into there, and that will mean this. We can find out what c is equal to. So all I've done here is I've substituted in y equals 6, x equals 5, and rearranged it to give c equals -4. Have we answered the question yet? It says, what is the equation of this line? Well, no, I haven't actually stated what the equation of this line is. So final thing, write the equation of L1 in full. So we've got y equals 2x, and we've added this c value on the end. Now c is -4, so we need to have a -4 there. Okay, that concludes the questions for foundation on equations of straight lines. Any questions? Please come back to me and I will gladly answer them for you. Okay, thank you very much. Bye-bye.